Today we will talk about Book 4B, Chapter 12, more about basic properties of circle. So last time we talked about opposite angles of cyclic quadrilaterals and also the exterior angles of cyclic quadrilaterals. So this time we'll have a look at the test for cyclic quadrilaterals. So let's have a look at some one new terms, concyclic. So what is a concyclic? So concyclic is actually the points lying on the circumference of the same circle. So in this case here, this diagram, PQR are concyclic. And last time in the previous chapter, we talked about that we can always draw a circle that pass through three non-collinear points. Non-collinear points, if you forgot about that, is actually just points that are not on the same straight line. So if we have any three non-collinear points, they must be a concyclic. And do you think it is true that four non-collinear points must be concyclic? So if we look at the examples on the right, you can see that point S is not on the circle. So therefore, when we have four non-collinear points, it is not a must to be concyclic. And in fact, not all quadrilaterals are cyclic quadrilaterals. So therefore, in this video here, we'll have a look at the theorems that can be used to test for concyclic points or your cyclic quadrilaterals. Actually, these come from the converse of some of the theorems we have learned previously. So remember, for cyclic quadrilaterals, the opposite angles add up to be 180. So therefore, if a pair of opposite angles of a quadrilateral are supplementary, then the vertex of the quadrilaterals are concyclic. So in this case here, if you can find that P and R add up to 180, or Q and S angles add up to 180, then you can say that PQRS are the concyclic points. And the reference we use here are opposite angles supplementary. So it's just like your previously we used opposite angles cyclic quadrilaterals, and then when we do the converse of that theorem, we use opposite angle supplementary. It's just like your parallel lines. You use parallel lines, but when you prove the parallel lines, you use supplementary instead. So make sure you don't write the wrong reason. And then there's another one. So last time we talked about the exterior angles of cyclic quadrilaterals. They equals to the interior opposite angle. So therefore, if an exterior angle of a quadrilateral is equal to the corresponding interior opposite angles, then you can say that the vertex of the quadrilateral are concyclic. So it's opposite. So if x and y is equals the ones in this diagram, then you can say PQRS are concyclic. And the reason we write here is exterior angle equals to the interior opposite angle. So it's like your wording, but you just write it out in the short form or the symbols. And then we have this last one. This last converse theorem comes from your chapter 11. So if the S and R are 2 points on the same side of the line segments PQ, and then the angle PSQ is equals to the angle PRQ, then the 4 points PQRS has to be a concyclic points. Okay, so therefore, this time you have to remember the shapes. Okay, so if x and y equals each other, then PQRS are the concyclic points. And this is the converse of angles in the same segments. Okay. So in fact, if 4 points can't satisfy the condition in theorem 3, 4, or 5, then they are not concyclic. And we're not going to talk about the proof of this theorem 3, 4, 5 here because it's a little bit complicated. We'll probably talk about it later. So let's have a look at some examples first. So in the following, please determine whether A, B, C, D are concyclic. So let's look at the first one here. So you've got a quadrilaterals. If the opposite angles add up to 180, so your angle A and angle C are opposite. If they add up to 180, so you realize 55 adding 125 is 180, then we can say that A, B, C, D are concyclic. And in this case here, we're using opposite angle supplementary. So make sure you write that out correctly. And then for 2 here, this 2 add up is not equals to 180, so therefore it is not concyclic. And then look at another one. So using another theorem, because you can see that this is an exterior angle of that quadrilateral, and if it is equals to the interior opposite angles, then you can say that angle ABCD are concyclic, using the reason exterior angle equals interior opposite angles. And then this one here, the opposite interior angles is this one, and they're not the same, so therefore it is not a concyclic. Okay, so and this one here, so look at it. So the angles in the same segments is the same. So therefore, ABCDs are concyclic, using the converse of angles in the same segment. And the other one here, okay, 58 and 62 are not the same, so therefore ABCD are not concyclic. Okay, so now is your turn. So let's have a look at example 5 together. So first one, okay, question A. So determine whether ABCD are concyclic. So in this case here, let's look at it. Which one would you be using? So opposite angles, I don't really have opposite angles here. I don't have opposite angles, so I can't use the opposite angles supplementary. And I don't have an exterior angle here. So therefore, the only way to prove it will be using your converse of angles in the same segments. But first of all, I have to realize, are they the same, right? So in this case here, how can we find it? So we have to find whether the ACD, okay, so here, okay, sorry. So let's highlight this here. Okay, so mean that I have to prove whether this one and this one is the same, isn't it, in the same segment. Okay, but the thing is, I don't have this angle ACD, so what should I do? So first of all, I should find this angle ACD first, and in here, this is a triangle. You got 2 of the angles, so you can find your angle ACD. So angle ACD, the add up should be 180 because angle sum of triangle. So angle ACD is equals to 40, and therefore is equals to angle ABD. So ABCD in this question part A are concyclic. And you have to give the reason, and the reason we're using this time is converse of angles in the same segment. Okay, and then the part B, let's look at part B. So part B here, this time, we don't have the exterior angle again, we can't use it. And they give you some information. Let's look at the information. So these 2 lines are the same, so therefore this is an isosceles triangle, and then the base angles will be the same. And once you have this angle here, once you have this angle DAB, then you can see whether these opposite angles add up together give you 180. If they add up to give you 180, then you can use your opposite angles supplementary to prove that they are concyclic. So because AB is equals to DB, so therefore angle BAD is equals to angle BDA. The reason is your base angles are isosceles triangle. And therefore BAD is actually 66 degrees. So have a try and see whether they add up together and give you 180. So angle BAD adding your angle BCD equals 66 plus 114, and it actually equals 180. So therefore B, C, D are concyclic points. And the reason is your opposite angles supplementary. Okay, and then the last one here. So obviously you can see that the last one, you got this exterior angle here, right? 105. And the exterior angle, suppose it should be equals to this opposite interior angle. But the thing is, we do not know what is it yet because we're missing this part. So first of all, we should find this angle first. So how do we find this angle? You can see we have a little bit more information here. Okay, so we got this parallel line here. Okay, we got a parallel line and we can find it. But the thing is, I do not know what is this angle as well. Okay, so how can I find these angles? So before we can find this angle, you have realized this is a straight line and they are all on the straight line, so they should add up to 180. So let's find this angle ABD first. So all this add up should give you 180 because adjacent angles on straight line. So angle ABD is equals to 40. And if angle ABD equals 40, then it means that, so let's give us some space here. It means that your angle CBD is equals to 40 as well, because of your alternate angles DC parallel AD, right? And then we can now find our angle ADC. Angle ADC is just angle ADB, adding your CDB. So it is 70, adding 40, and it gives you 110. And the thing is, we just said, I want to see whether this one is equals to your exterior angle. And your exterior angle is 105, so it doesn't equals to your exterior angle. So therefore, your A, B, C, D are not concyclic. Okay, so this shows that 3 different ways of proving. Okay, then we look at another example. So in this here, you got a figure, and then it asks you to determine whether your PQRS is a cyclic quadrilaterals, and then part B asks you to find the unknown x. So first of all, let's have a look here. Okay, so you got a quadrilateral shape here, and this is the shape you have to prove. And then look at the information they provide. You can see that you got an exterior angle here, and also you got the interior opposite angle. So therefore, if you can prove that they equals each other, then you can say it is a cyclic quadrilateral. So let's have a look. So your PST is given as 60 degree, and then the PQR, which is your inner opposite angles, is 20 plus 40 and is 60. So therefore, because this angle PST is equal to angle PQR, you can say that PQRS is a cyclic quadrilateral. Okay, and then the reason you use here is your exterior angle equals interior opposite angles. You can see that when I write the reason, it's just like when I say it out, so it's very easy to remember. And then part B is says find x. Okay, so x here, what is x here? Okay, so erase this part first so you can see it easier. So x here, again, remember this shape. What is this shape here telling you? x and 40 is at the same segment. So therefore, angle x is actually equals to your angle RQS, which is 40. And the reason is angles in the same segment. Okay, so then let's look at another example first before we move on to more questions. So let's look at one more example. So in here, we got a PQRS is a parallelogram, and they ask you to find the theta in part A, and then ask you to determine whether your M and RS are concyclic points. And then part C, if MN is equals to NR, find the angle NSR. So let's do it step by step. Let's look at part A first. So part A, find the theta. So what do we know about theta? So let's look at what information they give you. It is a parallelogram. So let's highlight this first. PQRS is a parallelogram. So where is it? PQRS. So this one is your parallelogram, right? So what do we know about parallelogram? So what is that telling you? We know that we have two pair of parallel lines. The length are the same, right? And then we only have this angle here, angle 80. So with this is the only thing you got, and you have to find your theta. So what can this tell you? So let's have a look at this part here. So I'm going to use this green highlighter and see if you can see it. So because of the parallel line, and you can see that this set shape, again, this set shape is going to tell you your alternate angles, right? And this one here is going to be 80 as well. So what do we know after we got these angles here? So this is 80. What can it tell you? This is an exterior angle of your cyclic quadrilateral, because where's your cyclic quadrilateral? This one is a cyclic quadrilateral. How do we know this is a cyclic quadrilateral? Remember, a cyclic quadrilateral is just that there is a quadrilaterals and or its vertex is on the circle. And this fulfills it, so therefore you know that this 80 is the exterior, and then the exterior angle of a cyclic quadrilaterals is equals to the inner opposite angle. So therefore you have your theta. So let's write down first. So MNR is equals to angle PMN, which is 80 degrees, using your alternate angles PS parallel QR. And then theta is equals to MNR, which is equals to 80 because of the exterior angle cyclic quadrilateral. Okay, we got this now. And then we have this part B. Determine whether M and RS are concyclic. So let's have a look whether it is concyclic. So let's erase all this first. A little bit messy here. Okay. So some of you might say, wait a second, these are like outside the circle. How can it be concyclic? But the thing is, they draw this blue circle here, but it didn't mean that these 4 points can't be on the other circle, isn't it? So therefore, you have to use the way the theorem you have learned to prove it, to show it, instead of just telling me, oh, there's no circle, so it's not concyclic. So let's have a look. So in order to prove it, what we have, so this is the shape we're talking about, right? MNRS. And then let's look at this one here. You got some information there helping you. So you got an exterior angle there, isn't it? Right? So you got an exterior angle, and if you can show that this exterior angle is gonna equals to the inner opposite angles, then you can say that they are concyclic. So that means the first thing you have to do is find this angle. How can we find this angle? All the information you have is on this side, isn't it? So everything you have is on this side. So how can you prove it? So if you want, you can write that. This one you have as well. So these are the only three angles you got. You got theta, which is 80 as well, and then the 80 degree they gave you, and also the MNR 80 degree as well, which you have proved. But you still can't tell me that what is your angle SRN, right? But what shape is this? This is a parallelogram. So where's your parallelogram? Let's highlight this. So this whole thing is a parallelogram. So other than that, you have, the parallelogram tells you not just about the parallel lines, right? The opposite angles of a parallelogram should equals. So therefore, when PMN is equals to 80 degree, this is the one they gave you, and then the QRS is equals to theta equals to 80 degree because of your opposite angles of parallelogram. Then you realize both of them is 80 degree. So therefore, because PMN is equals to QRS, therefore M and RS are concyclic. And the reason you use here is your exterior angle equals the interior opposite angle. So you have to always go back and look what information you have and how you can use it. And then the last one, it says if MN is equals to NR, find NSR. Okay, so again, erase this because it's a bit messy. So NSR is this one here. And then MN is this one, and R is this one. Okay, so what do we know about this? What are these two lengths here, MN and NR? It's not talking about the isosceles triangle because they're not on the same triangle, right? But somehow, if you just prove that this is a concyclic, meaning that at some point here, there's a circle, isn't it? Okay, so ignore my circle is a bit ugly. But you realize NM and NR are the chords. So equal chords equals angles. Okay, so you know that we will have this used somehow later on. And the angles we're talking about here is using a highlighter. So if we got this MN, then the angle we're talking about will be this MSN here. And then the other one is your NR, and the angle will be your NSR. Okay, so therefore, if we can find this angle here, MSN, then we can find what is your NSR. But do we know what is the angle of MSN? Okay, so let's look at it. We do not know what is MSN first, but let's look at the other parts, see if we know this one here. So we do not know what is MSN, but how about PSR? So this whole angle here. Do we know this angle here? We can find it because this, remember this whole shape here. This is a parallelogram, isn't it? Okay, so you got parallel lines. So if you know what is theta, then you know what is this here. So perhaps I should write down. So angle QPS plus angle PSR is equals to 180 because of your interior angles and then the parallel line you use, and therefore 80 degree adding your PSR is equals to 180. So therefore PSR is equals to 100. And because MN is equals to NR, so therefore MSN is equals to NSR. And the reason for that is equal chords, equal angles. So some of you might say, how do you know I have to find this PSR angle first? Because you know that MSN is equals NSR, and MSN adding NSR is the angle PSR. So therefore, actually, NSR is just half of it. So NSR is equals to half of your PSR. So therefore, half of it times 100, and you get 50 degrees. If there's no questions, perhaps we'll have a look at the consolidation exercise 12b and have a try at a few more questions. So consolidation exercise 12b, let's look at question 4 together. So question 4, it asks you to determine whether ABC are concyclic, and if it is, find the unknowns. So let's have a look here. So A, B, C, D here. So whether this is a concyclic, and in here you can see that so if you want to use the opposite angles and prove that whether they add up together 180, you can't do it because you got an unknown x here, and then we don't know what is this interior angle of D, so we can't use it. But you can see that we have this exterior angle 100 here. So therefore, if I can prove that the opposite here, which one is it? The opposite interior angle is equals to the exterior angle, then we can say that it is a concyclic. So in this case here, let's look at it. So angle ABC is equals to angle ABD plus your angle DBC, which is 70 and 30, equals to 100. And then look at your exterior angle, make sure I can write directly, is equals to your angle CDE, the exterior angle. So therefore, A, B, C, D are concyclic. And when you can prove that it's a concyclic using the reason exterior angle equals interior opposite angle, then you have to find the unknown. So the unknown x. So we can now say that this opposite angles add up to 180. So therefore, angle BAD adding angle BCD should equals 180 because of your opposite angles cyclic quadrilateral. And remember, we are using the cyclic quadrilaterals properties, so therefore you have to write this instead of the supplementary. So do not mix those two reasons. And therefore, x is equals to 138 degrees. So how about we look at question 5 as well. So whether this is concyclic, so whether A, B, C, D are concyclic. And in here, you can see that they give you the informations here and here. And if they add up and give you 180, then you know this is you know that those points are concyclic. So therefore, let's have a try. So ABC adding ADC is equals to angle ABD adding angle DBC. So adding all those together. So make sure do not write side by side and just write 180 on the side, because you have to show that you found that it is 180, not that you assume that it is 180. So put them into your calculator, you realize they're 180, so therefore you can write A, B, C, D are concyclic. And this time the reason is your opposite angle supplementary, because you're proving it. And once you prove that it's concyclic, then we have to find the unknown. So the unknown is y here. So how do we find this here? So look at this shape, this butterfly shape you have got. So therefore, we know that they are at the same segment. So angles at the same segments is going to equals each other. So y is equals to 42 degrees. So make sure you start memorizing all those different reasons and be familiar with the shapes as well. Let's look at question 13. So in this figure, ADC and ABE are straight lines, AB and AD are equals, and BE and DC are equals. And it asks you, is it true that triangle ABC is a congruence to triangle ADE? So for congruence, you have to prove that you have to have 3 reasons in order to show that is a congruence. So let's have a look. So first of all, let's look at what which triangle they're talking about first. So ABC, this one, and ADE, this one. Okay, and let's look at it. So you got the information that is given. So AB is equals to AD, that's given. So that's one of it. And then you have this angle here, which is in common. So your angle BAC is equal to your angle DAE. Okay, and this is a common angle. And you need one more information here. So the other information, let's have a look. You got some equals length as well, isn't it? So you can see that this length and this length. Your AD adding your DC is actually your AC. Okay, so your AC here. So let's write down first. So your AC is equals AD plus your DC, isn't it? And at the same time, you can see that these are equals as well. So, and this is your AB and your BE. And AB and BE add up together, give you your AE. So here you go, you got your AE. Okay. So therefore, you now have 3 reasons. So therefore, triangle ABC is congruent to triangle ADE with the reason of SAS, and therefore it is true. And then part B, it asks you to figure out whether your B, E, C, D are concyclic. So therefore, let's have a look. Where is your erase this first. So the points they're talking about is B, E, C, D. Okay. So whether your B, E, C, D are concyclic. So how can we prove that is a concyclic? So what shape is this? Okay, so this shape again, so you know that you want to use that converse of angles in the same segment. And then we have to look at whether the angles are the same. So your angle here and the angle here, are they the same? So using the reason from part A, because it's congruence proved in A, and therefore you can say that your angle ACB is equals to angle AED because of your corresponding angles, congruence triangles. And since they're equal, so therefore B, E, C, D are concyclic. And the reason here is your converse of angles in the same segment. Okay. And then let's have a look at question 15. So here they give you information of different angles and it's drawn on a diagram, and they asked you to figure out whether your A, B, C, D is a concyclic. And you can see that this is your exterior angle, isn't it? So if I can prove that my inner opposite angles is equals to it, then I can figure out whether it's a concyclic. And you can see that this is a triangle. We got two of the angles, so therefore the third one you can just find it using your angle sum of triangle. So add up to 180. So 36 plus 30 plus angle ADC equals 180. So angle ADC is actually 114. And then because your angle ADC is equals to angle CBF, your exterior angle, so ABCD are concyclic. So using the reason exterior angle equals interior opposite angle. And then they ask you to find the angle BDC. Okay, so once you know that is a concyclic, and then look at it. So your BDC and this shape here. So BDC, this green one is the one you don't find, and then you have this angle here. So because it's a concyclic, then you can say that BDC has to be equals to angle BAC because they are angles in the same segment. So equals to 48 degrees. Question 18, it says in the figure ABCD is a square. DP equals CP, and then the angle DPC is 90 degrees. And then there's one more information. I is the in-center of it. So what is the in-center? Do you remember? So in-centers, if you draw the line here. Okay, what does in-center mean? In-center means that, for example, this IC here is bisects the angle DCP. So therefore, the angle DCP, the angle DCI is half of your angle DCP because it bisects, so you cut it into half. So this one and this one is half of the whole thing, DCP. So here, let's look at other information. So CID is the angles you want to find. So CID is the angle you want to find, right? And then let's have a look. So other information they provide is you got this parallel line. Not parallel line, sorry. Same length. When you have same length, it means that this angle is the same as this angle because of your isosceles triangle. And if they provide you this already, the 90 degree, meaning that you can find these two angles. So let's write it first. So DP is equals to CP given, and therefore the base angles are equals. So CDP is equals to angle DCP, base angles, isosceles triangle, right? And because in this triangle CDP, we know one of the angles already, and the other two angles are the same size. So we can use our angle sum of triangle to help us to find it. So DCP is equals to CDP, so I'm just going to replace it. And two of those, DCP, is equals to 90, so angle DCP is 45. So once I got angle DCP, what should I do? So because just now I just told you, IC bisect this DCP, meaning that we know what is we can find our angle DCI with that. So with the notation, because I joined those lines, so I write with the notation, or you can just write at the beginning actually. Okay, Okay, so whenever you write something, make sure you write it right at the beginning with the notation. So I is the in-center of triangle CDP. So therefore, IC bisects DCP, and therefore DCI equals half of your DCP, equals half times 45 degree, which is 22.5 degree. So this is for DCI. But the thing is, you can see that these two triangle is exactly the same, right? They have the same side. DP is equals to CP, and then they have the same angles. They cut the IC bisect DCP at the same time IC bisect angle angle PDC as well. So therefore it will be the same. So you can just write similarly angle CDI is also your 22.5 degree. So once I have, so let's write out here. So once I have this 2 as 22.5, then how can I find this? I can just use my angle sum of triangle. So I write on the side. So DCI adding your CDI is equal to 180. Angle sum of triangle. So 22.5 adding 22.5, adding your angle CID equals 180. So angle CID is equal to 135 degree. And then part B, it asks you to determine whether AD, I, and C are concyclic. So let's have a look. So whether this is concyclic or not. So what do we know about it? So let's have a look which points. Actually, let's look at which points they're talking about first. So ADIC. ADI and C. Okay, so what do we know about these points here? So probably is easier if we draw the lines here. Okay, so with the notation, this time I also joined the line AC as well, because this is the points they want to talk about. And let's have a look. So how do we know whether they are concyclic or not? Okay, so this is part B, and then in part A, what have you found? In part A, you have found this CID here, right? So imagine this shape here. Maybe if I draw it here, it's easier to see. This shape here, the only information you have is this one, 135. And for it to prove whether it's a concyclic, if we can show that the opposite angles add up together give you 180, then we can say it's a concyclic. But the thing is, do we know this angle DAC? We actually know. Why do we know? Because this is actually a square. Okay, ABCD is a square, and then AC is actually the diagonals of it. So therefore, CAD is 45 degree with the property of square. And we want to prove that whether the opposite angles add up together give you 180. So we use CAD to add with the CID. So 45 adding to 135 give you 180. So therefore, it tells you that ADIC are concyclic. Using the reason opposite angles. Let's look at question 21 together. So 21 here. In this figure, ABC is a right angle triangle. And then it also tells you that, so let's highlight this first. And then they also tell you that CDEF is a rhombus. So determine whether ADGE is a cyclic quadrilateral. So let's highlight it, ADGE. So this one here. So you can see that we don't have any informations. I mean, like, when I say any information, I mean like exact numbers of your angles, because remember, if we want to prove that whether it's a cyclic, we can use the opposite angles add up together 180. We can also use the exterior angles equals to the interior opposite angle, and also the angles in the same segments are equal. But the thing is, we don't really have angles there except for this 90 degree here. Okay, so if we got this 90 degree, then let's have a look at it. So we probably want to say that the opposite angles add up to 180. But do we know what is this angle G here? So let's have a look. What is angle G? So because CDEF is a rhombus, and you can see that this line here, CE and DE, is actually the diagonals of that rhombus, and therefore we know that this angle here is actually 90 degree. So angle DGE is equals to 90 degree. So property of rhombus. So you can see that this part here is actually using your Form 3 quadrilaterals knowledge. And then we want to test whether they add up to 180, the opposite angles. So 90 plus 90, obviously it is 180. And therefore, ADGE is a cyclic quadrilateral. And the reason is your your opposite angles supplementary. Let's look at part B. So part B, it says, Steve claims that CDEB is a cyclic quadrilateral if AC equals AB. So let's have a look at the diagram. So maybe I'll have to zoom. Probably I can just rub this off first. So we can write part B at here, and then also have a look at the diagram, and also can be able to see all the information they gave us. So highlight this part, CDEB. Okay, so whether this is a cyclic if the length AC, so this is AC and AB is equals. Okay, so therefore you got a isosceles triangle. These two angles is going to be the same. Then we can also write it out first. I mean, like, sometimes you don't know where to start, just start with the information they provide. So this information is provided under part B, so therefore you definitely know that you can use it at some point. So write out first, and when you write out, then even though you haven't finished the whole questions, I can still give you some marks here. Okay, I got this part, and let's look at this. This is 90 degree. So meaning that I can actually find my angle ACB and ABC as well. Okay, because in the triangle ABC, all the angles add up together to 180. And you already know your BAC is 90 degree. So angle ACB is actually equals to ABC, so I replace it by ABC, 90 plus 180. So 2 of the angle ABC is equals to 90 degree, so angle ABC is equals to 45. But the thing is, even though I know this is 45, I still need to work a little bit more to find out whether the CDEB is a cyclic quadrilateral, right? So how do we know that whether it's a cyclic or not? the opposite angles equals, or the exterior angles equals the interior opposite angles, or you have the same angle, the angles in the same segments are the same. But the thing is, we can't see any angles in the same segment here. And when I talk about opposite angle, I don't really know what is this angle here. So it's not helping at all. Then let's look at it. Will it be the exterior angle? So the exterior angles are these two here. Do we know anything about this? So remember, this is your rhombus, right? And for rhombus, we know that you have some parallel lines. And can you see it now? Probably it's a bit messy. So perhaps I draw it here, then you can see it. We've got a parallel line here, and this is D, this is F. We found this is 45 degrees just now. And therefore, this angle here, you'll be able to find it because of the corresponding angles using the parallel line. So we can write that these two lines are parallel because of the property of rhombus. And therefore, we know that angle ADE is equal to the angle ACB, corresponding angles CF parallel DE. And therefore, it's 45 degrees. And this angles here is actually the exterior angle of the cyclic quadrilateral, and then the opposite interior angle is this one. So therefore, you can see that both of them is equals to 45, and therefore CDEB is a cyclic quadrilateral. Using the reason exterior angle equal interior opposite angle. And therefore, make sure you answer it because it says whether you agree. So therefore, the claim is agreed.